These are the notes for graphing rational functions, but using transformations. Okay, so here we're given two common rational functions, and the first one is the 1 over x. So we're going to talk about the quadrants first. So you'll notice we have 4 quadrants, if you recall from coordinate plane. This is quadrant 1, 2, 3, and quadrant 4. And you'll notice you have asymptotes as the y-axis and as the x-axis. So you got to remember your asymptotes are currently the x-axis and y-axis, and it gives you the equation. So for the vertical one, x equals 0, and for the horizontal one, y equals to 0. Now, one thing you need to know is that your branches are going to be in quadrants 1 and 3. So we can see here we have them in quadrants 1, and we have them in quadrants 3. Now, that's the basic one. Now we're going to apply transformations to that in a bit, but I just wanted to talk about that. For the other one over here, again, we still have quadrants 1, 2, 3, and 4. But this time, you'll notice instead of being x on the bottom, it's x squared. So when it's x squared, that means that your branches are going to both be going in the same direction. So notice they're both going up. So here, they're going to be in quadrants 1 and 2. So right now quadrants 3 and 4 are not being used, but again, the transformation can always flip it over. So if you see x to the first power on the bottom, your branches will more than likely be in quadrants 1 and 3 if there's no transformations. We'll talk about that in a moment. And if it's x squared, they're going to be in quadrants 1 and 2, both facing in the same direction. Okay, so let's talk about transformations. So notice we have both equations here, and let's just refresh ourselves on what these do. So let's start with the easy one, h. So remember, insiders lie. Let's try a little nicer. So here we have insiders lie. And h, it means it left or right. Your k value is what it is, and that moves it up or down. And now your a value, I'll talk about it. If a is greater than 0, that's a vertical stretch by a. If a is less than 1 but greater than 0, that's a vertical compression by a. But what we really want to look at is when a is negative. So this right here, if it is a negative number, so if a is less than 0, that means it's negative, then it reflects across the x-axis. Okay? And that's when you really have to be paying attention to. That a value is negative, whether it's -1, -5, because the vertical stretch, vertical compression, you're not going to see it as much, but the a value is going to switch the branches, right? So we know currently they're in like quadrants 1 and 3, but if your a value is negative, they switch to quadrants 2 and 4. All right. Now, again, I don't really need to talk about a, h, and k, because on the squared one, they do the exact same thing. K moves it up or down. H, insiders lie, so fix the lie and then move it left or right. And the a value, vertical stretch, vertical compression. But again, if that a value is negative, so here, this one's pretty easy. Instead of facing up, both our branches would be facing down for this one. So this one would look something like this. Whereas over here, if our a was negative, then it would switch from quadrants 1, 3 to quadrants 2 and 4. And right here, actually, it tells us, I didn't see that, but it says negative a flips the function over the x-axis. H determines the horizontal translation, left or right. Remember, insiders lie, and k moves it up or down. Okay, so let's go ahead and get to these. They're very easy to do. Determine the parent function, plot the new asymptotes of transformations, plot the new graph. So in terms of this, here's what I expect to see. So we're going to start with our parent function. So right here, this one, x squared. Now you notice it gives a graph already that they're facing up. Things we need to remember is we have our our asymptotes at the x-axis and the y-axis, so I'm going to graph those in there. And then we're going to talk about the transformations. So the 1 does not have a reflection because it's not negative, so we don't have to worry about that. This is h. Insiders lie, so it's actually a 2. And that's a positive 2, so it goes to the right 2. And that affects your vertical asymptote. This is the k value. It's positive, so we go up 1. So I'm going to move my asymptotes. So originally it was at the x equals 0, which is the y-axis. We're going to move that 2 to the right. So 1, 2, and I'm going to graph this one. So this is right 2 units. Notice I'm just moving the asymptotes. And then this one right here, I'm going to move it up 1. Okay, now look at the parent function. The branches are both in quadrants 1 and 2. So all we're going to do to make this graph is we're not going to worry about trying to find points. We know they're both still facing up, so we're going to put one in quadrant 1 and the other one in quadrant 2. Now when I say quadrant 1 and quadrant 2 for this one, it's a little exaggerated because it's not really quadrant 1 and 2, but compared to the asymptotes, it's 1 and 2. So right here, we have one branch hugging the asymptotes in quadrant 1 and the other branch hugging the asymptotes in quadrant 2. Notice they're both together because my parent function had them originally together as well. All right, moving on to the next example. For this one here, we see 1 over x, which makes sense that our asymptotes are in quadrants 1 and 3. And if there was a reflection, it would go to 2 and 4. Okay, so I start with the a value right here. I see a negative sign. Go back on top of the notes. That's a reflection across the x-axis. This is your h, insider's lie. That's a negative 2, so that moves to the left 2 units. This is your k value. The k value is negative 1. That is down 1. Okay, so we're going to go and move our asymptotes. So the vertical one, we're going to move that left 2. So 1, 2. So here's my left 2. My k1 was down 1, so we're going to take that one that was on the x-axis and move it down 1. Now, originally, my branches are in quadrants 1 and 3, but since we have this reflection across the x-axis, they now move to quadrants 2 and 4. So this is quadrant 2. Notice I'm just getting close to the asymptotes, and this is quadrant 4. Again, this is quadrant 2 as in comparison to the asymptotes, and this is quadrant 4. Okay, next example. Or actually, that appears to be all the examples. All right, and that's all you're going to need to complete the assignment for today.